All right, we're back. This is page 53 of math analysis, and we are trying to write equations for trig functions given their graph. And so this is a sinusoid. It's not necessarily sine or cosine. It's just a sinusoid, and it depends on where we decide to start. So I'm going to try to get the information that I need. So first thing I need is a maximum, and you can see it's really no reason. It's more work than you really need to do here, but you can see that that's at 7. The minimum you can again see is going to be at 1. And so let's get those. And then the sinusoidal axis is the average of those. So add them together, divide by 2. That's going to give me 4, right? So 4. And you can kind of see that. Well, you can definitely see that if you look going straight. Whoops, that's not a highlighter. Here we go. Going straight across 4, you can see that's definitely the sinusoidal axis. So what does that tell me? That tells me that the amplitude, which is the absolute value of A, is 3, because I can go up 3 this way. I can go down 3 this way. So you always really want to do top, take away, bottom. So it's really 7 minus 4 is 3, or 4 minus 1 is 3, or 7 minus 1 is 6, but that's twice the distance. So then divide that. So we know that the absolute value of A is 3. We don't know if we're going to use positive A or negative A because we don't know where we're starting yet, but once we decide that, we'll be able to do it. The period in this particular case is like a little harder to find because when you look at it, our maximums are not occurring on like lattice points where the grid comes together. So I'm probably not going to use those, and minimums suffer the same fate. So instead, what I'm going to do is I'm going to look at it and I'm going to say, you know, if I go intercept, minimum, intercept, maximum, intercept, that's definitely a period. So I know that the period of this is 3. So that's the period. And then what I want to do is I'll use the period to figure out what B is, right? So I know that 2 pi divided by B is equal to 3, which means B is going to be 2 pi. Well, why am I not writing B? So then B is 2 pi over 3. So that'll be 2 pi over 3. And then D, we already figured out the sinusoidal axis was 4, so D will be 4. And now we have to decide like where we want to start, right? So it's actually really useful to know the increment. So if the period is 3, the increment is 3/4. Now the reason I think that's important is I think that 0 is a very good starting point. If I start at 0, I'll do this, and you can just look at this. So you're starting at an intercept and going to a minimum, negative sign. So let's write that one. So starting at 0, at x equals 0, we're going to get a negative sign graph. So I'm going to say it is negative 3. So f of x, negative 3 sine of B, we said was 2 pi over 3. Quantity x minus 0 is our start, and then plus 4. All right, so now what I'm going to do is I'm going to move one increment and see what I get. So starting at 0, I got negative sign. Move one increment, and I'll be starting at a minimum, so I get negative cosine. But the question is, how far is that? Well, one increment we calculated was 3/4 over here. So if one increment is 3/4, then if I start at x equals 3/4, I'm going to get a negative cosine. So f of x is negative 3 cosine of 2 pi over 3 quantity x minus 3/4, so minus the start, and then plus 4. So that'll work as well. So let's basically do it again. So I'm just going to keep moving by an increment. Once I have like one good starting point, just keep moving one increment at a time. So if we start here, we will get a normal sign graph, so a positive sign. So that's going to be at, so what's 2 increments? So one increment was 3/4, so 2 of them is 3/2. X equals 3/2 or 1.5. I prefer to use fractions if I can. So it's going to be a positive sign. 3 sine 2 pi over 3 does not change. X minus 3 halves. And then plus 4. Then if we go one more, so one more starting point, we'd have to start up here. Well, we'd want to, right? Because you basically just want to go like from a good starting point and just go keep going and increment over. So that's positive cosine, and that's going to be at x equals, what are we at? We're at 3/4, 6/4, 9/4. X equals 9/4. So count by 3/4 because the period is 3, an increment is 3/4, so count by 3/4. And we got f of x is, what did we say? That's a positive cosine. I mean, it's got to be a positive cosine because that's like the last thing. Yeah. So 3 cosine 2 pi over 3 x minus 9/4 plus 4. All right. So all of that's really good. The next question that we want to answer is, what if we started here? So if we start there, this question really kind of boils down to, what is that coterminal to? So we're really trying to answer, what starting point is 1055.25 coterminal to if the period is 3? Wait, that's not a question mark. There we go. So what is that coterminal to if the period is 3? If we could figure that out, then whatever we had for that. So like say that that's coterminal to 3/2, right? If that's coterminal to 3/2, which it's almost certainly not because it ends in 0.25, but who knows? If it was coterminal to 3/2, we would know it's a positive sine graph because at 3/2 we get a positive sine graph. If it's coterminal to 3/4, then we know it's a negative cosine because at 3/4 we get a negative cosine. So we just have to figure out what this is coterminal to. Is there a tricky way we could do this? I think maybe if you think about multiples at 3, the sum of the digits must be divisible by 3, right? So what I'm thinking that I can do potentially is I think I can break 1055.25 into a multiple of 3 plus some extra. So that's what I'm going to try to do. So I'm going to do 105. So that's 6. So if I add another 3, it's still divisible by 9, and then plus 2.25. So this is going to be the thing it's coterminal to. So it is coterminal to 9/4, which means I think that we get a positive cosine. So I think we'll get f of x is 3 cosine of 2 pi over 3 x minus 1055.25. Whoops, no, 1055.25 and then plus 4. So what I'm going to do is I'm going to graph them and see if we got it right. So let's switch over to a calculator page, or a calculator, and graph. So I'm going to graph 3 cosine of 2 pi over 3, quantity x minus 9/4 plus 4. All right, so that's one of the graphs. And then I'm also going to graph 3 cosine of 2 pi. And if this doesn't work, it's there was a flaw somewhere. 1055.25, and then plus 4. It's exactly the same. We got it. All right, that's good. That's like that's a confidence booster, right? So say you did it wrong, right? Say you did it wrong and you thought that it was a sine graph. So it would not overlap. Like we would be very obviously wrong. Like here, if I thought it was like a negative cosine, you can see it's just off. And then what's the last one? Negative sine, maybe? The arrow's right. Well, that no matter what I do, I got something in the way. So you can see the only one that actually worked was the one it was coterminal to. It was coterminal to 2.25. if you're doing it on the calculator, I guess, you also have this option. So on the calculator page, you could have done, so this is like way back, floor of 1055.25 divided by 3. And so it's 351 full revolutions. So if I do 1055.25 minus 351 times 3, that's your principal coterminal angle. So you could also have done that. I thought in this case, because I know, you know, I guess it's a trick, I don't know, the pattern of numbers that are divisible by 3, the sum of their digits is also divisible by 3. Since I knew that, I was able to break it up into the closest multiple of 3 that I could find, which was 1053, and then whatever's left was the coterminal. But so this is all a good problem. I'm going to come back in the next video and finish this page. So I will see you there.